So maybe some reminders that we all need when we're graphing this, that whenever you graph it, if this is cut off on the top, how could I fix this to where I can see the whole thing? Yeah. How do I change the window? Window. Which really, when you're in the graphing, when your menu is going to get you a lot of things. So if you're stumped, you're trying to look for an x-intercept or a max, something like that, go to your menu, and you can kind of play around with it until you get there. But yeah, if we go menu and then our window, we could either go window settings. Sometimes a standard zoom is going to help. That's like a -10 to 10 in your x-axis and y-axis. But for this one, we're going kind of high. We've got a diver that is jumping from a diving board that's 32 feet above the water. So he's actually jumping up first and then going down. So we want our y max to be higher than 32. Maybe we make it like 50. Make sure we include that. So that way we can at least see the max. Yeah. Whenever we are sketching a graph of this, what might be helpful to know? Yes, they're impressive. That is part of the problem for sure, that they're an impressive diver. I mean, they're diving from a diving board that's 32 feet above the water. I'm not sure that I can imagine that. That's pretty high. So. Well, what else did you guys find out when you sketched it? Or did you just go for it? Okay. The max might give us a good idea. So back to our menu and then our analyze graph. We've got a lot of options. We can find a 0 or an x-intercept. We've got a max as an option. It's one of those that's going to ask you to go to the left of your max and to the right. Oh, lower and upper actually. But that is what it means. And our max is about at 0.5. What are you talking seconds? And we're at 36 feet. So if we want to at least give ourselves a max here, we could call that 36. And then, I don't know that it's worth labeling the rest of it, but we can at least get a good idea of this guy that starts at 32, and he goes, whoop, and he goes, and now he's underwater, so I guess we can keep going. So technically this parabola has a left of the y-axis, or left of the y-axis doesn't make sense. Sometimes we have this happen where we have an algebraic representation of something where part of the domain doesn't make sense for what we're talking about. If we're talking about time, of course there wasn't negative time, but there was time before he jumped off the diving board, so I don't know. Do with that what you will.
That was him climbing on the stairs.
Yes, he was climbing up yeah. Probably not as quickly as he fell though, so climbing up the stairs is going to look a little different. We're really needing a piecewise function here to represent the two different things. Okay, Lana, how are you doing?
I'm still trying to figure out the window.
Okay.
I don't know.
Getting to the window, or you're changing it?
I'm changing it.
Okay. So I would just make sure that your y's go above 36, because that's the max. And if we wanted it to be the only thing in the window, I could change, we're only going from 0 to 2 seconds here. So we could change our x max to be like 4, so that we're only seeing that part of it. That changes it up a little bit too. We could go from 0 to 4 if we didn't want to see him going up the stairs or that inaccurate part of it. That makes it look like he didn't fall as fast. It was like, whoa. Okay, getting there. Okay. Congrats. So if you haven't, let's go ahead and sketch it so you have an idea of what it looks like. So now we're going to move on to part B. We're finding the average velocity, or the rate of change at which the diver is moving for the time interval from 1 to 1.5. So we're looking at, so here's our diver at 1. They're not quite at the top, but a little bit past it. They're falling now. And then 1.5 be somewhere in here. And we're looking for that average velocity. What does it mean if we are finding an average rate of change? What are we doing? What is rate of change? Slope. It is slope. And since we're talking about time over distance, time and distance, that means that whenever we look at that change, the change of distance over time, whenever we find slope, it will be velocity. So if I find the slope here between 1 and 1.5, the slope answer is going to be that average velocity over the time. Okay, so we're going to look at, which mine's looking kind of linear right now, but we're going to look at this average velocity here. I feel like I maybe made it a little sharper than it should have been. So how do I find that slope? What do I need?
2 points.
I need 2 points. Okay, so we've already graphed it. So in our calculator, if we are looking for f of 1, we can go back to our menu. We can trace, so your 5 is your trace, and graph trace is the easiest, and then we can plug in whatever we want. So we need to know at 1 what point we're at. So we get 132, so that's one of our points here. And then we also have our 1.5 is at 20. Okay, so now how do I find the slope? Yeah, the slope formula, where we're subtracting our y's. So I've got 32 minus 20. So these are both giving me a point. I've got a point 132 and the point 1.520. So I'm subtracting my y's over subtracting the x's. Should this diver's average velocity over this time interval be negative or positive? I'm not sure what you said. Positive. Okay, we're about to find out. So we've got our 32 minus 20. We got a negative 0.5. So it ends up being negative. What does that mean if the velocity is negative? Okay, it's a negative slope. Yeah, we can see that with our graph. It was a negative slope, and so it is going to be a negative velocity. Do we know why velocity can be negative or positive, but speed can't?
You can only get faster than 0 speed.
Okay, so our sign is talking about direction. So what direction is the diver going? He's going down, or she. So since they're falling, and sometimes velocity, when we have negative, it will mean like left versus right. That'll be our negative and positive. Sometimes our negative and positive is talking about falling versus rising. So this is telling us that this diver over this interval from 1 to 2 is falling at a rate of negative 24 feet per second. Okay. How fast do you think the diver is falling at 0.5 seconds?
Nothing.
They weren't falling. They're at the top, right? There was that brief moment before they actually started falling. So at 0.5, they were at the max, so they had a 0 velocity. They were not falling or rising. What do we think about at 1 second? What did that velocity look like? They were still at the top, but they were starting to fall because they were at the top at 0.5 seconds. So this is the average velocity over that time interval from 1 to 1.5. Okay, so it was an average. It's not an instantaneous. How fast do we think they're falling at 1 second? Do we think they're falling faster or less fast than they are over that time interval? Less fast. It's right after the max, so it's taken a while for them to for gravity to take its role in all of this. Okay, so that's where we're going to figure out.
Is that the 36 and the 32, so then just do that?
Okay, so if we're talking instantaneous velocity, so we're wanting to know their velocity at that point, we're actually looking for the slope of this line. I want the slope of the tangent line, because the slope of this line gave me the average over those two interval, or over that interval. I want to know what is the velocity from 1 second to 1 second. Like, it didn't go anywhere. I want to know what is the instantaneous velocity right there. So the slope is going to be a little less. Okay, but we don't really know what it is just yet. Okay, so we're going to flip over a purple sheet. We'll get there. Okay, so this is going to be this is going to take a second. So we're going to find some other average velocities, starting with looking at the average or the velocity from 0.9 to 1. That means that we're plugging in other things, and we're going to tag team this a little bit. So for the 0.9 and 1, we're doing the same thing that we did for the last one. So I would need to plug in, go back to my trace, and plug in 0.9. So I get 0.9, 33.44. We already know what is our point for 1. 32. Okay, so if we find our slope for that, that means that we would be taking our 33.44 minus 32, so that'd be like a 1.44, and then dividing by my 0.9 minus 1, so dividing by a negative 0.1, and we get a negative 14.4. So this would be the average change in between, the average velocity between 0.9 and 1 second. If we look at the average rate of change, or the average velocity from 0.99 to 1 second, should it be closer or further from the velocity at 1?
Further. Closer.
It's going to be closer. Why?
Yeah, okay.
Do we see why? That window is getting smaller. We're getting closer and closer to just talking about like instantaneously at 1, because 0.99 to 1, that's really, really close. We're right there. Okay, so we're closing the gap. Okay, so we're going to split up some things here, and we'll discover what this is all about. So we'll have Matthew and Zeddy up here. You'll do the 0.99 to 1. All four of you, because this one's going to be very small, you're 0.999 to 1. That's what you guys are doing. Alex and Ashley, you can do the 1 to 1.1. And then Logan, oh goodness, why did I just forget your name? I'm so sorry. No, you don't. No, you don't. You're going to do 1 to 1.01, and then I'll do this last one. Dakota. It's like, why did my brain just, it stopped. It's probably just because I was going through saying, it's also because I'm filming this, that's, for some reason, that hurts my brain sometimes too. Just the fact that I'm filming it. When you plugged in, you got more decimals than you.
And I did it, and I
It
did
shouldn't
it.
affect it that much though. Oh, you're missing a decimal. You should have done 20 with the way that you have it. So you divide by 20 and then you one. Should have gotten a difference of 0.2 for the numerator. Yeah, you got 0.2 up here, but then you use 0.02. So it would get you a -20, which is actually kind of close to what you were using. But it changed your, or you're gonna get more decimals, yeah. Where are we going? No, he didn't. He told me he did, but he didn't.
He scared me.
I don't know. I don't know what's happening. Also, I printed out myself one that you could see better on, and then I didn't use it. I'm crazy. Okay, so let's hear from people. My 0.99 to 1 people. What did you get? Negative 15 point what? 84. Sounds good to me. Our 0.999 to 1. Negative 16. Just straight up negative 16. All right. My 1 to 1.1 people. You got negative 17.6. Okay. Okay. And our 1 to 1.01.
I guess we're just that cool.
What did you have?
Negative 16.
Negative 16. Well, and I think mine is wrong actually. Because how did I get 17 though? Because it should be getting closer to 16 actually. Now, these guys, I feel like you should have more decimals in there. Your 16 was probably like a 16.16, something like that. So you might need to look at your calculators to make sure that you're getting more. Sorry, this is like a negative 16.02. It's really close to negative 16. I had one job. I messed up my one job.
So mine
Huh?
will be rounded.
Yeah, I think it's just a rounding thing. You're fine. Okay, so let's look at what's happening here. Whenever we were looking at this 0.9 to 1, what was the distance of that interval?
0.1.
Okay, so this distance was 0.1. Okay, whenever we looked at the distance between 0.99 and 1, what's the distance there?
0.01.
0.01. And then we looked at the distance 0.999 to 1. 0.001. Okay, so out of these, which one should be the closest to what the instantaneous velocity is at 1?
0.999.
This guy. Yeah, we got really close there. Okay, then it kind of starts over. I really probably need to make this table where it goes in instead of out, but it's okay. It starts over from the other side because now we're looking at 1 to 1.1. So this is on the other side of 1. What is the length of that distance, that interval? 0.1. Okay, so this is the same as this guy. It's just on the other side. So if we were from 0.9 to 1, it's going to be less velocity. He's not falling as fast because it was closer to the max. Where this is after 1 second. So from 1 to 1.1 seconds, he was falling faster. But as we get closer, now our 1 to 1.01, now we're 0.01 away. And then our last interval that I messed up here is 0.001 away. Okay, so what do we think the instantaneous velocity is at a time of 1 second? It is a negative 16 for sure. Okay, so this is what we're doing. And this is just our intro into this, and we'll spend like 4 days on 2.1 on like the introduction to derivatives. We will spend a lot of time here. But what we just found was a derivative. So we can go ahead and answer that we're estimating the instantaneous rate of change at 1 second would be about negative 16 feet per second. And the slopes that we were looking at, every time we were looking at a slope, we always had 1 involved, but then we also were looking at either adding something to that or subtracting something from it. So we were always looking at some slope that involved 2 points, where one of the points is 132 in this case, so 1, but f of 1. And then we're also looking at some point where we've added something to it. So we've got like a 1 plus some other value, and our f would be, or our y would be f of 1 plus some other value. So every time you found a slope, you were looking at these 2 points. You had f of 1, and then you also had some point that was next to it. We were taking 1 and adding an h or subtracting an h. And we found that point. So our slope would be this f of 1 plus h minus f of 1 over our 1 plus h minus 1. So looking familiar? Say it again? Oh, yep, that's what I'm going to do. For sure. Oh, and I change it to an x. Mm-hmm. Okay, so this is how we found the average slope between the 2 points. We had our point that we knew, the f of 1, and then we were always looking at another point. Now to find instantaneous slope, we needed those points to get closer and closer together. So our instantaneous slope is going to equal the limit as our h goes to 0, because remember that h is whatever we're adding or subtracting from 1. So that distance between the length of the interval, that's our h. We're looking for that h to go to 0 of f of 1 plus h minus f of 1 over h. So essentially we were saying with our graph, here's our graph. We were getting those intervals closer and closer to 1, where maybe we would look at these two, and we look at 1 in these 2 points, and 1 in these 2 points, until eventually the gap between the 2 points that we were looking at are so close together that I found the instantaneous slope at t equals 1. So the only way that we can do that, the only way we can find instantaneous velocity is through calculus, by finding the limit as h goes to 0. Because we know that there's never actually an interval of time that goes from 1 to 1. Nothing happened. Like, there's no time there. But we can look at what happens when we approach there being no time in between. Okay. So that is where we are going to pause as far as getting into 2.1. We will look at some different representations of our derivative things each day, but do we have questions over our diver question here? Okay. So we're going to go ahead and move over to the orange sheet. We do have a little bit of time here. We got about 14 minutes. We're going to move over to the orange sheet. If you have already answered the free response, then you go and work on the multiple choice, but the rest of us are going to go ahead and attempt the free response. You are trying to decide if f is continuous at 3, and then explaining why or why not. You do need to use limits. So I'll give us a few minutes to do that. And then we'll at least have time, I think, to go over this question, and then we'll just have a few multiple choices. Let's go. We don't have enough time to talk about it, so let's go 5 minutes.
Why do you think some of them were?
One of them has 5 on the right, and one of them has 5 on the left.
this one. I don't know.
It had a first class into it.
This one with
It had a first class into it, I mean,
Yeah, it was like this. X. Alright, was it negative X? I don't remember. It was either positive or. I don't know if it was either positive or negative. I don't know.
Oh, yeah, I did.
It is, yeah, it is. There's an S there.
Is it positive?
From the right,
Yeah.
yeah.
It is? Okay, because I'm getting confused on this one. Well, I don't know how to do it. I was plugging it in, but like, I kept plugging in numbers.
I think it was, I think it was X minus, I think it was a positive
what
five
if
and
you
X
just
minus
cross
five.
these two X's out?
Yeah, it might have been that. It's one of them. I just know that you couldn't plug it into the bottom because it would have been, like a.
No.
It's probably done wrong.
I think I got like this.
Because like, so, if it's negative, if the infinity is negative, or I mean, if it's not, like if the number doesn't go to be negative, but it gets.
Wait, so I have this. So that would have been a zero then.
Does it still, does it get to be zero if it gets? No, not clear. I mean, like,
So it was an X minus five and then five, but you're right, it would be positive infinity, because if you plugged in things from the right, 5.1 is going to be a positive number. But it's
I'll
going to
just
be
look at it. That's what I thought. Like,
I think yours was just from the right, but it was somewhere else.
Oh, so that's the one I was thinking of. I was thinking of the one that has the infinity. That's
not when you use.
For that one, you look at horizontal.
yeah.
Well, then I think I got that one wrong.
Oh, so I probably got it right. It would just be tough.
If we're learning from mistakes, that's going to be
So,
Okay, so we should be finishing up the orange sheet. If you're not working on one, you will start it.
I think it is continuous.
I forgot how to write.
The limit to
Yes.
Figure out this greater than that.
But this is how we're starting, so this is like the y. It's like when x is greater than 0, the y.
How did you write it using limit though?
Were you ready for the?
I was.
Okay, let's go ahead and talk about it. Make sure that whenever we are given any AP practice, which is our very first AP practice actually in AP Calc, that we are attempting it fully, because that is the way that we learn from our mistakes. That's the way we see, I don't know, how maybe we could have gotten points by doing something even though we didn't fully know what we were supposed to do. Because a lot of the AP test is just showing what calculus knowledge you do know. And sometimes you don't actually know what you're doing, but you can still get some points by showing what you do know. So always try something, even if you are not sure if it's correct. So first, did we decide that this was continuous at 3?
Yes.
Okay, it is. And so I added this in. They're not going to tell you to use limits, but you should be using limits. If you are answering a free response question and not using calculus, there's probably something up with that. Every once in a while there will be something like that where maybe we can explain it without using calculus, but it's rare. So even though we could have decided in algebra 2 if that was continuous or not. We plug them in and they work, but we need to use limits. So we're looking at, you should be writing the limit as x approaches 3 from the left. And as we talked about before, if you want to replace the f of x and say that that is actually the limit as x approaches 3 of that top piece, that's the left piece, you could. And then we're just plugging in 3. So we get the square root of, square root of 4.
It could be plus or minus 2 technically.
And it wasn't because.
It wouldn't, so the square root of 4 is always 2.
True.
The only, when you're getting the plus or minus is when you have an x squared equals 4. Now x could be positive or negative 2. Yeah. And then from the right, so we're trying to show that it is continuous, so our limit has to exist, and then a few other things that we need to show. So you could go ahead and plug in 3 to the bottom. I do think it's helpful to go ahead and write that we're actually finding the limit as x approaches 3 at that 5 minus x. Me too as well. Does that prove that it's continuous? No, not quite. We're almost there. If the limit is the same from the left and the right, what could be true? Could be a hole. So how do we show that there's not a hole?
When you do f of that value.
F of 3. Okay, so at this point, I can either go ahead and show, we've actually already done f of 3. Where did we evaluate f of 3?
The top.
Yeah, it was the same as the left because that's where 3 was included. So f of 3 is the same as when we plugged it in there. So you could either take a new step and say f of 3 is going to be this 2 times 3 minus 2, and you're re-showing that limit from the left. Or it is perfectly fine to not show that whole step and to just say right here that 2, that 2 especially, you don't want to put it here because that's a little confusing, but with your left-handed limit that is going to be the same as f of 3. You're welcome to list that right there. Okay, in the end, we want to make sure we answer the question. So what is our answer to this question? Yes, so we want to say, especially if it's saying, is it blah, then we should be saying yes or no at some point. Sometimes students will launch into an explanation without actually saying what their answer was. So we're going to say yes. The function is continuous. At x equals 3 because, and this is where our definition or steps for what it needs to be continuous come into play. So we want to go ahead and state what we just found. So we're going to go ahead and say the function is continuous at x equals 3 because the limit as x approaches 3 from the left is the same as the limit as x approaches 3 from the right, which is the same as f of 3. And for response question, this was an actual question from an AP test. This is just part A. So you ended up getting 1 point for showing the limits and f of 3. And then you got 1 point for your explanation. So you'd have 2 points. You did all those things. Whew. Hey, sometimes you take all that you can get. So if you have not attempted the multiple choice, that is all your homework that you've got. You have how many were there? 4 multiple choice questions. Fully attempt. That is it. Enjoy your weekend.